Well, good morning, Objective by the Sea. It is lovely to be back. There are a lot of new faces, which definitely makes it more intimidating, but there's still all the friendly ones here as well, so we're good to be back. We're all friends here. Yeah, welcome to all the new people, and thank you for coming to our talk. The clock is ticking. So I'm Calum Hall. I'm a co-founder of Phorion, the macOS security company. This is my fellow co-founder, Luke Roberts. We spoke here a few years back doing some offensive research, and as of late we've been doing some more defensive work, and hopefully kind of making it a little bit easier for the good guys. So to give you a kind of quick run through as to what we're going to be talking about today, we're going to be giving a really quick speed run of TCC, just to kind of lay the foundations for the rest of our talk, give a kind of high level overview of how it works, what it looks like for both the user and somewhat to the system as well. We're then going to give an attacker's view of TCC, so how red teamers, offensive security operators, many of the people in this room go around finding bugs in TCC, abusing it, and some of the interesting parts there. We're then going to be looking at increasing visibility and gaining visibility into TCC itself. And last but not least, to keep the crowds happy, we're going to be dropping a tool at the end as well, as Patrick mentioned. Cool. So what is TCC? So TCC, or Transparency, Consent and Control, is a security and privacy mechanism that Apple implements in an attempt to kind of restrict application access to different resources on the device. So these can be different components, like your webcam, your microphone, that kind of thing, or they can be logical resources, such as different system folders. This can be pretty crucial for not wanting applications to be able to read things like your session cookies for browsers and stuff like that. So it's a pretty great idea from Apple, TCC, but we're going to talk today about some of the not so great sides of it as well. So to kind of give an example of under the hood what this looks like at a pretty high level, here we have terminal wants to access the microphone, makes the request, the operating system steps in, reaches out to the TCC daemon and says, hey, should terminal be able to access this resource? The TCC daemon then goes out and queries a bunch of on-disk resources that it knows about. So the kind of most common, the one that most people will be familiar with, are the user's TCC database, system TCC database, but we also have things like the MDM overrides plist, which allow organizations to manage TCC permissions at scale for their enterprises. And we also have app entitlements, which is kind of, we're not going to go too much into that, that's kind of an Apple thing, but that can also allow applications to access certain resources on the device.
Okay, so my day-to-day is much more on the offensive side, so there couldn't be a talk that I do without jumping into that a little bit. So from an attacker's perspective, what are we going to do about TCC? It's something that we have to consider on almost every operation, because, like Cal mentioned, there's various things on the device that we want to get access to that we otherwise couldn't. So the first way I'll talk about is just having full disk access. A lot of developers, security people, I might wager, have given their terminal full disk access to begin with. If you can operate inside of that terminal, you inherit its TCC permissions and you can move out there and do all kinds of fun stuff. There's no user interaction required. As Calum mentioned, this is just the user's TCC database, not the system, because that's SIP protected. But from there, we can change things, we can put in our own entries, and manipulate that as we see fit. The next side of this is a exploitation or a bug. TCC has been dismantled, I would say, over the past couple of years at OBTS by many people in this room. Tons of bugs that allow you to effectively take over the permissions that an application already has, and then go and cause some problems with that. If you saw the dirty nib vulnerability that came out last week by Adam Chester, it's another great example of this type of work, piggybacking on a legitimate app, and I believe there's probably a talk later on, I'm sure it's today or tomorrow, but on Electron fun with this as well. And the last approach is just my personal favorite. You just annoy the user into clicking yes. If any of you have the pleasure of using Slack, you'll notice that it prompts you all the time to install helpers and things, and despite how many times you click no, it always comes back and asks that one more time until you just go, okay, fine. So this is super fun as a red team. You can prompt, you can reset, you can prompt again. And as I'll go on to say in a second, TCC prompts aren't the most verbose, so it's kind of hard to work out actually what you're seeing. Okay, problem number one. What does this actually tell us? So terminal would like to access the microphone. I like that it puts terminal in quotes. That's a good precursor to what I'm about to say. Yeah, it's hard to know what this actually means. If you are like me, this is usually roughly what your desktop looks like. And this probably happened to me. Like, terminal popped up, it wanted access to the microphone. I had, I don't know, 15 terminal windows open, running all kinds of various homemade tools and things I've got from the internet and, all the rest of it. And I had absolutely no idea what that was. And that caused me to react a little bit like this, panic, and was one of the inspirations for this talk and the tool that we've made.
So to kind of jump into the next problem we've identified with TCC, TCC is gated by bundle ID and not version. So if you download an application back in 2019 and you need that application to run, so you give it all of the TCC permissions it asks for, that application continues to run in the background, you kind of forget about it. Applications change, updates come out, vulnerabilities are introduced. We've seen some pretty concerning stuff with this with Night Owl, where applications are bought over by parent companies with, let's just say, not great ethics, and start using them for malicious purposes. The difficulty with that is those applications remain to have the same access they had when you first downloaded and installed them. So without being controlled by version, it's really difficult when applications change to maintain what they use that access for. Problem number 3 is a lack of TCC usage information. Now, there are kind of two sides to this. The first being, some of us just want to know what our applications are actually using. We might want to do some cleanup and say, does my application actually need this TCC permission? And if so, can I just remove it? We don't really have that information. On the other side of that, we probably want to know if applications are using TCC resources when we wouldn't expect them to be. So is this application using my microphone when I'm not expecting it? Is it attempting to access my downloads folder at 1 in the morning every single night? These are things we probably want some kind of insight to, and with TCC as it currently stands, we don't have that visibility.
Okay, right, so let's get some visibility. So TCC, and being an Apple system process and being a security system, is hardened against people just poking it. You can't inject a DLL like you would in Windows. You can't kind of look inside of it and start augmenting it in that way. You have to almost find like things that it's doing that you can hook into that Apple's given you. The one that we found the most use here is the unified log. TCCD writes out to the unified log all the time. And starting, I don't know exactly when because I couldn't find some versions old enough, but some number of versions back started giving really, really detailed logs on what it was actually doing. This includes things like when it's prompting, what it's prompting, when a subsystem asks for a TCC permission and the results and why it's the results and all these kind of things, which is super useful for us. There's also tons of things in here that are not structured, super hard to use, and are effectively just debug messages being the unified log. So there's a bit of kind of finagling required. So I'm going to pull out these 6 different log types. These ones are fairly structured. There's loads more, as I said, but these are the ones that kind of build the picture up for us and provide us with a data source we can use to then make reasonings about TCC. So the first log entry is a request. I've highlighted the bits that we pick out as being useful. The first thing to mention here is this message ID. The message ID is the PID of the subsystem which is making the request. So if you're in terminal and you ls the downloads folder, that would be sandboxd. And that is appended with a kind of sequence identifier, which increments as you kind of go about these requests. And then a function. There's a few different types of functions, but the one that's most important for us is this type of access request. So using this message ID, we start pulling all these together, and we pull out the next one, which is a context, and we'll provide some context. And the most useful thing here is this actual concept of the service, like what is our application trying to give access to, which is in this case downloads. Next, we move on to attribution. This is arguably the most useful. Now we start getting into the meat of it. We can actually see the various system processes that were involved in this. So the top one, what I should say is this responsible accessing and requesting process are not always there. There's not always all three of them. Sometimes there's two of them, sometimes there's one of them. Sometimes what you would see here is the responsible being this like top level bundle will be in accessing. There's so many variations of how it's requesting, depending on what it is, how it's been launched, what service it's asking for. This all kind of gets moved around a bit. But this is a good example because we've got all the information that we can to work with. So starting with the responsible, it's kind of like rolling up to this top level bundle, and this is what you would typically see in one of the prompts. So terminal, we know where it is, we know the PID, and we can start enriching the information from there. But where it gets really useful is when we start moving down to this accessing layer. So now we know that it was LS that did this. We know the PID. We can start pulling signing information from this. We can actually get useful information to make a determination about what is actually asking for a resource. And lastly, requesting, and this is what I was saying a second ago about the subsystems, where sandboxd is responsible for gating access to the various system folders. In a sense, that's the one actually making the request. Next, we have the subject. This is what would be displayed in the prompt. Just kind of tells you of the fields previously which one is the one that will actually be entered into the database. Because I'm not sure if we covered it earlier, but when you're making these requests, these are all gated by this top-level bundle identifier. It's not by ls, it's always by this top level as we roll up. The next one is prompting. This kind of combines all the information we've seen previously. The most important thing about this is the fact that it exists. If it exists, a prompt has been displayed to the user, and that happens immediately. If it doesn't exist, it means that TCC was able to make a decision some other way. As we'll see in the result, which will tell you what the result was, a 0 being denied, 1 being unknown, 2 being accepted, and the auth reason. There's a big old list of these. 3, I believe, is that the user set it themselves. There's also an auth version field, which I thought was interesting. It's always 1, even on Sonoma, as far as I'm aware, which allows Apple to kind of augment this in the future if they so desire. Okay, so as you've probably noticed, we're practically grepping out the unified log here. It's not crazy robust. We're augmenting with an Apple internal system which does not want to let us in. We're almost trying to like find side channels to understand what it's exactly doing. The OS does not want to help us here. To kind of give us a level of like safety and understand what's going on, and also help in development, to be honest with you, we implemented a GitHub Actions workflow which matrices across all the different macOS versions that were available. And this allows us to prompt or make a TCC request, check all these logs, pull them out, check they exist, and look to see if they have changed. And oh, they change. And they change in really small, annoying ways. So in macOS 11, this is what it looked like. This is actually what I started with, and I thought this was great. Wrote all my regexes. Moved over to macOS 12. We've got a new way of kind of representing this, I assume, because this is now an object rather than a dictionary, but I haven't diffed the binaries to work out specifically. And macOS 13, the angle brackets just disappear. So that was fun. Probably should say that Apple could just like remove all of this tomorrow. They could change the information that's presented. They could add new information. They could just get rid of it. And the best thing for us would be if this type of work was implemented actually into TCC, and the user then has the option of seeing this information. But for now, this is all we've got.
Cool. Thanks, Luke. Yeah, like Luke says, I mean, the ideal here is, hopefully you're about to find out, is that Apple takes what we have done and then do it themselves, so we don't have to maintain it. I mean, like that's the end result there. But until we get there, to kind of bring this all together, we've talked about some of the challenges of TCC, some of the lack of visibility, the lack of control to a certain extent. Luke's just talked us through the logs that we have access to and how we might be able to use those. And so we're introducing Kronos. Now, Kronos is a tool that we have developed to enhance the capabilities of TCC. It's not to replace or anything along those lines. We effectively want to make TCC more transparent and to provide you with more control over the permissions that you're granting. So a huge part of this is when you get that little prompt that comes up on your screen saying terminal wants access, Kronos will jump up beside it and say this is the actual thing within terminal that wants access. So you can see things like the binary path, the PID, that kind of thing. And you can actually make a reasonable judgment as to whether or not you want to grant access to that application. Hopefully this isn't great for red teamers, and hopefully it gives blue teamers a little bit of juice to work with there. We also want to encourage the principle of least privilege. I mentioned that we want to introduce some more control into TCC with Kronos. We'll talk about this in a second, but we want to be able to offer users the ability to retract TCC permissions after certain conditions are met. And visibility. Visibility is huge. That is what we are ultimately trying to increase here, is just people knowing what is going on within their underlying system. Most importantly, this is going to be open source, which hopefully means that you can all contribute to it, hopefully means you can all tell us where the bugs are. We also want lots of feature requests as well. Hopefully you'll see that there's plenty that we can still improve on, and there's plenty to build on. We've kind of left the door open for opportunity, especially in terms of conditions and things like that. So from a transparency perspective, we have the permissions tab, which is effectively the system preferences tab on steroids. We have taken what system preferences shows you in terms of the TCC permissions. We're giving you data like the auth value in terms of denied, accepted, the auth reason as to why a TCC permission exists, and the last modified for that TCC permission. So when was it created? When was it last changed? Hopefully that can kind of give you an idea as to when a certain permission was given or when it was last changed. We also provide signing information, so you can see all of the applications that have TCC resource access, if they're signed and who they are signed by. And we also are providing usage. Now, the usage for ourselves was a big one. We want to be able to provide users the ability to go and say, what TCC resources has WhatsApp been using on my device lately? Like, how often is it using the microphone? I've only video called once in the past year, so there shouldn't be any more access requests than that. So we have a full log off of the logs that Luke just talked about. We are storing those on disk in our own database where you can then reach them, you can then read them, see things like the accessing path in terms of what the actual resource underlying that was accessing that TCC resource, as well as the accessing result. So was it a success? Was it able to use that component, or has it failed? We're also revoking permissions. So we actually came up with this last year sitting at Objective by the Sea, which was pretty fun. We see JIT being used everywhere across the enterprise, especially with SaaS applications. And it's the kind of thing that just should be built into TCC. You should be able to grant a TCC permission and say, okay, this application should be able to access this, but only for the next hour. We have provided yourselves with the ability to go in and say, let's redact that now because I'm only going to use it once, or ask me again in 3 months' time because I might not be using this application anymore. So we really want to be able to give that control back to the user and hopefully kind of follow the kind of principle of least privilege that we talk about so much in security. Last but not least, we also have an endpoint security license, which is great. So we figured we'd do some good with that. We're also monitoring for, Luke mentioned earlier, the ability, if you have full disk access, to directly edit the user's TCC database. We are monitoring for direct edit attempts to the TCC database. So if offensive operators are attempting to go around and directly edit and insert permissions, we can detect that and notify the user, which is pretty great, especially for personal use where people don't have the ability to rely on endpoint detection and response tooling.
Okay, so what are the next steps? Number one is bug fixes. There's going to be a few of them. Please use it, find the bugs, tell us about them, or submit a PR if you're feeling kind. The next big thing in terms of features, we really want to be able to say, okay, this application version is version 1, version 2, revoke all its permissions. There's been an update, take them all away and prompt us again. We don't know what that code is, we need to remake our decision. For really short-term permissions, I want to make this phone call and then call it a day. Revoke these permissions as soon as the app closes. There's no need for it to be sitting there having all this access. We want to do some more work on the UI, and then just take your feature requests. If you have things that you want to improve or you think that could be good, drop us a link and we'll try and work on it. That's our talk. Thank you very much. So this will be available. It's not up yet. It will be available as soon as we get back on keys and can push it all up. So that'll be soon.
Do you think it would be useful if Apple pushed TCC notifications and more information as an endpoint security event? So you could, and can you repeat the question for the live stream?
Yes, so Patrick's question was, do we think it would be useful if Apple kind of pushed a notification through the endpoint security framework when a TCC event or prompt happens? The answer is yes, yeah. We're kind of hoping that this kickstarts them a little bit. I mean, TCC is a great idea. There's just some little things that they could do to make it a lot better. If it's something through the endpoint security framework as well, it means that kind of all endpoint detection tooling can pick it up as well, which hopefully makes it easier and more available to everyone. Cool, any other questions? Yes, Mikey.
What was the most interesting thing you discovered while you were building this?
Look.
Oh, yeah, tons of stuff. Yeah, I think maybe just the subtle changes between OS versions were probably the really interesting one for me. Just in the way that it's outputting these logs. I didn't super expect that, and they are really small, subtle changes. And I'd love to know exactly why that is the case, but that's going to require some more time and some more reverse engineering.
Yeah, and I'd piggyback onto that UI development with Xcode and Objective-C is not fun, and we should all be grateful for Patrick's tools. So thank you for the open sourceness. Cool. Any other questions? Happy days. All right, thank you very much.